Hello, and thank you for joining us. My name is Jason Proctor. I'm an advisory systems engineer for cyber recovery in the Global Technology Office at Dell Technologies. Today, we're going to cover cyber resilience, combating the 21st century disaster. So as we're all aware, cyber is the new disaster. You have more of a likelihood of getting hit by a cyber incident than you do of pretty much any natural event going forward today. Obviously, there's plenty of statistics around it, and you're welcome to review these at any given point in time. But I think by now, here in 2020, we're well aware of the threats that are out there. And we're well aware of where organizations are as it pertains to those threats. Obviously, if things were taken care of, we would hear less and less threats. But in reality, we're at the point now today where we've had more threats identified within 2020 than all of 2019 combined. And that's important. Things are accelerating on a very rapid basis. And one of the reasons, obviously, with the pandemic, chaos begets chaos, and they just keep adding on. It's not if, but when you're going to be a victim. And in fact, your chance of being a victim in the next 2 years is almost at 1 in 3, as compared to 1 in 4 just in the report a year ago. So again, things are accelerating. And nobody is immune. It doesn't matter what vertical you're part of. It doesn't matter what country you're part of. It doesn't matter where you're at or what you're doing. You are not immune to being hit with a cyber attack. So some of the notable ransomware attacks thus far, I mean, there's 10 here on this page. A couple to take a look at. Obviously, TravelX is one of them that led off the year. And in fact, they are now in administration as a direct result of that cyber attack. But another one to note here is Toll, which is a logistics company based in Australia. Not only did they get hit in February, but they also got hit again in May. So it's not something that it's one and done. It can happen again and again and again and again. Now, this is 17 different versions of well over 100 attacks that I found within this article that's noted down in the bottom. I just took some of the notable ones. Just know there's a lot more that are out there. So why did we develop a cyber solution? So this solution was developed roughly about 6 years ago in direct response to the Sony attack that took place. Now, what we found with a lot of the attacks that take place, in fact, the large majority of those attacks take place when somebody breaches the network. They actually are in your network for an average of 206 days. There are a lot of studies around this one. And what they're doing, not only are they looking around for your most critical infrastructure, where do they need to place their bugs, but also for your critical data. What are they going to be able to attack and take out of there to force you, in essence, to pay their ransom? Otherwise, they're going to release the data, and you're going to have to rebuild from scratch. Now, obviously, that dwell time is before the actual attack, which does take place here in between the breach and dwell and response and containment periods. That actual attack is when you get that blue screen of death that says, pay us this amount in Bitcoin. Otherwise, we're going to go ahead and release the documents, and you'll never see your data again. So that's important to note. What we're looking to do is take advantage of this window of opportunity when it comes to breach and dwell time to be able to identify a threat, to be able to identify a compromise, to be able to find the problem before it actually becomes one. Because the problem really starts once this attack actually takes place and you get that blue screen of death. This here is an example of the Norsk Hydro cyber attack that took place earlier this year, taken directly from the article at Bloomberg Business Week. Starting at day one where the attack actually launched, where they got that blue screen of death. You know, they lost 500 different servers and 2,700 PCs. It wasn't until 7 days later that they were at least to a manual process. And then it took them over 5 months to be able to rebuild and recover that environment. Ultimately, this cost them roughly about $60 million to be able to do, but there was a true fear that they were going to lose the business because as a direct result of that cyber attack. So what our goal is to find the problem before it becomes one, so that you're not actually hit with that blue screen of death, that you're able to stay in operation. And that's important. So there's a lot of misconceptions today about how to protect yourself from a ransomware attack. Everything from encrypting the data to a traditional DR type response to it, adding more security, throwing tapes at it, putting retention lock into production, and they all have their pluses, but the one thing that they all miss is that the data still remains on the production side of the network. Anything within production, because the bad actor is there, they are hiding in plain sight, and in a lot of cases have credentials. Anything in production is subject to compromise. It's subject to be destroyed. That's important to note. When we built this solution, we built it with three key principles in mind. One of them is building that air gap and taking it off of network. The second one is making that data immutable inside of that air gap, creating that worm, putting retention lock around it so it cannot be changed once it's been captured. And the third piece is proactive analytics. Again, that capability to identify the problem before it becomes one. And we'll get into each one of those segments here in a moment. Ransomware is targeting backups on a regular basis. The why of a ransomware is to get money. That's their number one goal. So how are they going to at least attempt to ensure that you pay the ransom? Well, they have to get rid of any and all ways for you to be able to recover so that you do have a higher probability of having to pay the ransom. And one of the ways that they do that is by completely destroying the backup network. Whether it's the catalogs, the servers, the media that it's stored on, that is their goal. Their goal is to force you to pay. So, a lot of different agencies out there in the world today, they all suggest having an air gap, taking your data off network. That is extremely important in this day and age. As we said, with the 206-day dwell time, they're looking around, they're stealing data, and they're hitting your most critical systems to give you the least probability of being able to recover at the time of attack. That's what they want. They want to force you to pay. And in fact, what we've done is we're the only endorsed solution by Sheltered Harbor, which is around the financial services industry to provide confidence in that system and in that industry. But for a data vault, and you can see the 6 different metrics that are looked at from the Sheltered Harbor group, for a data vault, we are the only endorsed solution around a data vault for the financial services industry under the Sheltered Harbor standard. So when we built this around the NIST cybersecurity framework, which has 5 basic components to it: identify, protect, detect, respond, and recover. So from an identification standpoint, obviously you want your critical workloads and the data associated with that. That's what needs to be in the vault. And how do you determine what is the critical data? Well, depending on your maturity level around your disaster recovery footprint, you've typically done things like application tiering and dependency mappings and things along those lines. So the lower the tier, the more critical, the lower the RTO and RPO, the more critical that application is to the survival of the business. So those are the things that we take a look at that should be included within the vault. But then we put it behind that logical air gap, and we put that compliance level retention lock around it. And the reason for that is, obviously, we want it off the network, but we also want to make it immutable. Even if something were to get in there, it can't do any damage. Then we provide the detect phase, which is those proactive analytics to discover those anomalies in the corruption within the data, finding the problem before it becomes one. And then if we do find something that is potentially causing the data to be corrupt, we give you the forensics report around it, not only so that you can go and quarantine on your production side the affected files, and I did say files, not entire data sets, but also the last known clean copy of those files that you can bring back into production in short order to be able to ensure continuity of business. And then that bringing back is all automated, that you can bring back a clean copy of the data, shortening the cycle from days and weeks down to hours, if that. Typically, if somebody were to be hit with a cyber event and decided to rebuild their environment, they're typically out for just over 2 weeks as of right now, completely out for just over 2 weeks. And that was something you saw in that Norsk Hydro cyber attack that I showed you earlier. It took them almost a week just to even get back to manual processes, let alone anything else. So we use the best of breed when it comes to backup and when it comes to disaster recovery to build your cyber resilience strategy. Again, cyber resilience is something completely different, but it does leverage the tools that you're using today. So from a backup perspective, rather than 100% and multiple copies and long-term retention, you're only looking at 15 to 30% of the data. And again, those are identified in the lower tiers of a disaster recovery plan. Those are the crown jewels of the organization, those things that you need to be able to operate at a bare minimum. And then your critical rebuild materials, which I'll show you examples of those here in a little bit. But then on top of it, we do build that physically separate and secured environment behind that logical air gap, and we make that copy with retention lock immutable. But on the other side, what we do is we only look at 14 to 35 days of that data, because we're able to successfully find a corruption or an anomaly within a data set, typically within one backup cycle. So there's no need for, whether it's 2 months or 6 months or 2 years or 7 years worth of data, stay in the vault. And we can do that because of the proactive analytics and reporting that go along with it, that are part of the overall solution. But it does require disaster recovery level response, a run book, an incident response plan. And just like your backup, you need to validate that it's taking place on a regular basis. And regarding just like disaster recovery, you do need to test your capabilities on a regular basis as well. So not only do we have the secure data isolation, but we also have that CyberSense Vault analytics, that proactive analytics. That allows us to provide accelerated data recovery, as well as cyber recovery planning that needs to go in place to have an effective strategy. So from our standpoint, we're using native features within the solutions that we provide today. So that's that file sync, that fast copy, and that retention lock. These have been around on Data Domain for many, many years, and is one of the many reasons, or some of the many reasons, why Data Domain is the most trusted data protection appliance out there in the world, and most deployed data protection appliance out there in the world today. So again, we segment the vault off the production network, and we build that air gap for that single point of entry. And it is hardened. It is hard-coded. It's 256-bit encryption, so that it cannot be breached. We have done multiple pen tests. Several firms outside of Dell have done multiple pen tests, and that air gap has not been able to be breached. So everything from the vault, that's managed from the vault, is done within the vault. It does not rely on anything in your production network to operate. And in fact, when a replication is done, that is pulled across by the vault. It's not pushed across by that production side. We create those isolated gold copies. We update it on a set schedule or randomizer, depending on what you prefer. We built it all on a REST API framework. We have multiple REST APIs out there for integration and things along those lines. We enable that analytics, and we built it all on a modern experience. So we do have the dashboard here that I'll show you an example of, and ultimately what you're looking at there on the left side are going to be the alerts. Not only security alerts, but also infrastructure alerts. Did you lose a drive? Is there a problem with the software? Things along those lines. Did a backup not complete? The status of the vault itself. Is it locked? Is it open and replicating? Things along those lines. And any jobs that might be taking place at any given point in time. And what's the status of those jobs? And if there is a corruption found, there is an alert that goes out. That does go out via email. And in the body of the email, you're given the details. What was the backup set? When was it completed? Was it clean? Was it dirty? Things along those lines. But then you're also given a CSV file. And that CSV file focuses in on the 106 different statistics that are looked at in every single backup set that comes across. Now, you get all the information, but one of the biggest things that you're going to see differently between this solution and a traditional anti-mal or IDS or IPS is we actually can identify the attack vector. And those are the commonalities between all the different ransomware attacks out there. We don't care what the attack is. We only care about what they're trying to do. And that's what makes this significantly more effective. So from a vault overview perspective, the basic components of a vault are going to be the data domain itself, as well as the vault management server. Vault management server controls all the cyber recovery. The SMTP syslog, that's going to handle your messaging and things along those lines. Your infrastructure server, so that's going to be your Active Directory, your DNS, your NTP, things along those lines. As well as the CyberSense, that's that proactive analytics that I'll get more into detail here in just a minute. And then also a console. Obviously, you need to be able to have a console there. Now, in addition to that, what is recommended is going to be a copy of your backup application. As I stated before, backup applications are a target in production. So having a copy of that set up and in a warm environment within the vault itself provides a faster response time. Same thing with a test recovery environment or sandbox environment. When you do a recovery, that you bring it back so that you can apply any patches or updates since that backup took place that you had done in production. Both of these are not required, but they are highly recommended because just like in any other scenario, you're only as fast as your slowest piece. So if it does take you time to put the backup application and the test recovery server in there, it just adds time to the overall process. And if you're going to put the vault at a tertiary site or something else along those lines, a jump server to enable remote management. Obviously, security protocols are in place, but to enable remote management if it's not sitting there on site in the same physical location, even though it is logically and physically separated from the production network. So as we've covered before, everything that happens from the vault happens within the vault. So at the time of synchronization here, step one, the vault actually puts this connection together between the production data domain and the cyber vault data domain. And it says, okay, send me over my stuff, bring it over here. And once it receives that indication that that sync has been completed, then it breaks this connection here and reestablishes that air gap. Now keep in mind, this is a secure connection between these two devices here. So the security is very high on that. Then we take and we put a fast copy on it and add the retention line. That creates the immutability. So even if something were to get in, and in fact, that's what we're hoping for, is in order to find something, you got to have something get in there. It does not have any compute to run. It's still sitting in that compressed and deduped and backup apt raw data format. So there is no compute to run. There is no way to run an executable from that backup set, which protects the integrity of the vault itself. Because we need to identify through those proactive analytics if there is a problem with that data. And again, we're not rehydrating that data to make it happen. We're doing it in the raw data format. So if we do find an anomaly, we already know the last known clean copy was the most previous backup to that. So we know what to recover, when to recover it, and so on. We obviously have the monitoring and reporting there, as well as the ability to recover through an automated process. And again, we're recovering the files. We're not doing a full restore of the data set. We're recovering those last known clean copies of the files that have been compromised as indicated by the proactive analytics with CyberSense. That way you can do a direct mitigation on your production network while at the same time bringing clean copies back. So again, it's integrated with the solution itself. It does scan for changes in data, not typical of the user behavior. It's looking for those signs of a cyber attack. And it does run a full content analysis versus metadata only. And that's important because it increases the accuracy that we've got going on from 88% to 99.5%. And I'll show you how that happens here in a minute. But from the CyberSense perspective, it's a three-step process. So it runs a scan, it indexes that data once it comes across. And once it's done there, it runs those 106 analytics that I had referenced previously against that data set. And once it runs those analytics, then an analysis is taken. So not only are we looking for, file entropy, similarity, corruption, mass deletion, creation, things along those lines, but we're also looking for those specific attack vectors that are found in pretty much every single ransomware attack that are out there. And in fact, the ransomware attacks actually only use about 6 of them most commonly, but there are 27 that we have identified. Now, this process repeats on an ongoing basis and able to compare and contrast to other previous scans, other previous indexes, so that it shows how your data changes and learns from that. And then the investigative portion of it. So it gives you those forensic reports to show you the who, the what, the when, the where, We know the why, it's money, but the who, the what, the when, the where, so that you can effectively be able to recover before an attack even takes place. So around the full scan versus just file metadata only. And when the index is done, and then that first analytics is done, it's taking a look at metadata and the headers itself. And then at that point in time, we take a look at that document content. So it goes through a multi-step process. But what that does is it gives you a much higher accuracy rate from 88% to 99.5%. And that is extremely important when you're doing a proactive look for potential cyber threats within the organization. As stated before, we've identified 27 specific attacks that are out there, of which 6 of them we see most often. So whether it's a strong encryption with original file name or with an obfuscated file name, it doesn't matter. Those are the things that we are looking for. The one thing to keep in mind, the ransomware tools that are being used out there, they're just variants of previous tools. They've been changed enough so that the user or the bad actor can actually hide in plain sight. They have user credentials, but they're also laying landmines as they go, but they need those landmines to not be detected by any anti-mal software. They need to evade those things, and that is what allows them to be there on average for 206 days, hiding in plain sight, doing what they do prior to actually launching the attack. Well, we take a proactive approach, and we're looking for the indications through these 27 different things that are the different attack vectors that are there. And that's very important because we don't need to be told what to look for in order to find it. We already know what we're looking for, and we're looking for those commonalities. So just to recap, we do that comprehensive index. We do the security analytics as well as the machine learning. So we're looking at those multiple statistics and those 27 different attack vectors. So if you do receive a notification, you'll get the full corrupted file listing details. You'll be exactly told what files are corrupt and when they became corrupt, and the breach user account and executables that might be associated with that. But then it gives you a support for recovery of the last known clean copies. So that way you don't have to necessarily stop production. You can quarantine those specific files and bring the clean copies back in, allowing you to recover within minutes to hours versus days to weeks. We do have enhanced security protocols as well. Things like Unisys Stealth, which provides a zero trust microsegmentation environment, or if they're located within the same physical environment, obviously physically and logically separated, we can use data diodes, light emitting data diodes for permissions, not only one way in, one way out, but also bidirectional as well. These are enhanced security protocols depending on what your security policies are. We do have those capabilities as well. And this is an example of the Unisys Stealth microsegmentation. What it does is creates communities of interest to allow permissions, and it's completely hidden from the production network. Nobody knows that it's there. So it's not able to be tampered with from a bad actor standpoint either. Now, obviously, the things that we're protecting on a regular basis, we are protecting those unstructured files. We are protecting databases as well as core infrastructure. And that goes to the critical rebuild materials that I'll show you here in a minute. The direct indexing of those backup images. So, and we do support Net Backup, TSM, Networker, Avamar, and Commvault. But keep in mind that we are not rehydrating that data. As I said before, we are looking at this in its raw data format. You don't need the original backup software to be able to handle the direct indexing. You do need it when you're doing a recovery, obviously, but you don't need it when the indexing and the analysis is taking place. So it becomes a very secure way to be proactive. And then the size of the servers and things along those lines, that's all variance based on the amount of data that's being processed at any given point in time. And we do look at the front end data in those instances. Obviously, we do have a methodology around our business resiliency services framework, the steps that we take from a Dell Technologies perspective when working with our clients, and those are illustrated here. And ultimately, what we're doing is we're leveraging the same key components around the disaster recovery for cyber recovery. Even though they're not identical, they do rely on each other, and they do have a lot of similarities from having a run book, having an incident response plan, and things of those of the like. We do provide those advisory services, whether it's a one-day cyber recovery workshop just to reference everything, through a multi-week advisory and roadmap session, all the way through custom, depending on what your maturity levels are at today and what you have today versus what you might need to do to produce an effective cyber recovery strategy. The implementation parts, we start with a project kickoff and overview. We go through, based on your metrics and your needs, design and harden that vault itself. We configure the infrastructure accordingly, and then we provide a recovery test to show that we've met or exceeded the expectations of that vault. We do also, for obvious reasons, also offer through our SecureWorks and Dell Technologies Services arm, things like incident response. You can even have a $0 retainer that if you are subject to a ransomware, that we can be called in and help as things go. But we can also look at security consulting and threat intelligence services and things along those lines as well. So around those critical rebuild materials, so we've been doing this, as I said, for just about 6 years now. And we've learned a lot over that time frame. So, we're looking at things like AD and LDAP, DNS dumps, event logs, boot records, configurations, proprietary algorithms and source codes that you might have inside, things along those lines. And the reason for that is if in the unlikely event that you have a mass catastrophe incident, where maybe it was an insider attack and they came in and they literally launched the attack as they were walking out the door. They didn't bother with the dwell time because they already had permissions to be there. But they launched the attack while they're walking out the door. Well, there was no window to be able to proactively look at that. This way, it gives you the tools and the capabilities that up front, so you don't have to rebuild from scratch should that have to happen. We know we've got a solid copy of the data, and that takes us so many steps forward. But you also then have all the config files and everything else for anything that might have been damaged that you're not starting from scratch. And just like anything else, we've got significantly more information online, on Twitter, on LinkedIn, our social media channels, on YouTube and things along those lines. So definitely some things to take a look at. We've even got case studies and the like. And with that, that brings me to the end of the presentation. I do appreciate the time and the opportunity. If you have any questions, please feel free to reach out. And otherwise, have a great rest of your day.